So it looks like you saved the batch as well. So see, that's nice. It labels everything. And then we'll just, so you just have one file. It builds up.
Mm-hmm.
I'm just going to put them side by side.
Yes, some. Yeah.
And I'll show you how we can overlay that data.
Mm-hmm.
Basically, we just have to combine the data because it'll give you I'm just going to close out of some of this. Okay. Okay, so we're going to put those two. Oops. Just open both of them at the same time. One more, right? Okay, you may or may not do that. There's just four, right? So there's four, 1, 2, 3, 4. And I got them all, right? That's everything, right? 1, 2, 3, 4.
Mm,
These are not Excel files.
okay.
Those are the batch files, I think. Yeah. See, it says BSW batch. Yeah, so it saved. You save this. You can only open this batch file using that software.
In the software.
Yeah. That's why we had to convert the batch
To Excel.
Excel. So we're only saving the Excel files because these are not going to be any use to you unless you're using this spectrometer, unless you have the same type of spectrometer, UV vis spectrometer.
I guess so.
And if you do,
No, not in my computer, but in the other lab.
yeah. So
Yeah.
you'll have this data too.
Yeah.
I mean, you'll have it so you can
Yeah.
just look at it without having to graph it. Is what I'm trying to
Yes.
say. Okay. All right. So, okay. So what do we? So you said that you want to overlay
Like
the absorbance
the
spectrum.
absorbance spectrum without duplex and the one with duplex.
Okay. All right. So are these without duplex? Probably shouldn't have. All right. Okay. So the first one. God, you have a lot of files.
Go down the no, you go more. That one.
Okay, so the first file, control for Benzoyl 3 to 4.
Yeah, that is without duplex.
Okay, so we want to overlay this data,
Yeah.
and the second one is
The second one is the one that we have increased the concentration value 4 to 3 times, because
Is it this one?
no, that one is the one we increase the concentration, and the second one is the same thing with the low concentration, you remember?
Oh, yeah, okay.
Yeah,
I think we want to plot this,
the one with the low
the
concentration,
higher concentration. Oh,
because
no.
the duplex was run with the low concentration.
Oh, right. Okay, so we wanted to plot this one, okay, with this one.
Yeah, that's why I was expecting maybe to.
Okay. All right, so we just want to plot these two sets of data.
Yeah.
Okay, so let's first, okay, so the way, okay, so I'm just gonna get rid of some things here. I'm only one, you can see it's got the wavelength written so many times. Oh, this is the duplicates, right?
Yes.
Do we want to? We just showed that there's not a statistical significance between the two. You know what I'm saying? So we're not going to plot the duplicates. So, but I'm going to make a space for that. Okay, and then this. So I want to plot this data, right? This is the data with the. I got out of there again. I'm pretty sure the second one is with the duplex. So.
No.
No?
That one is not a duplex. The duplex is mentioned like a DNA.
Oh, this is the one with DNA. This is without the DNA. This is this is the one. This is without the DNA. Okay, I got it. I'm just. This is the one with the DNA, right? What did I just do? Let me undo that. I'm confused. The first set is with the higher concentration. This is the DNA.
Yeah.
What's this?
The first one is the higher concentration. The second one is the low concentration. That the absorbance was down.
Oh, and this is what we want to plot, right?
Yes.
Okay. Okay. All right. I got it.
So, but this and this both are 2 microliter for ox and bisbenzimidazole.
Okay. Just copying and pasting because I want a label on the absorbance data, not the wavelength. I just need, all we need is one x-axis. And if you're going to plot other stuff, this is the way I do it.
You copy the absorbance and paste it again?
No, I was just see how there's the wavelength. I'm trying to get rid of that. But the problem is that it gives the name over the wavelength, not the absorbance.
Okay.
So I had to copy the name. I'm just copying the name into the next column because there's no name for that absorbance. You know what I'm saying? And it's just redundant. You don't want to plot this 4 times.
Okay.
Because it's the same values.
Yeah, because same values.
And then the other thing is it only gives you the name above this.
Yeah,
You know,
and then
so-
you remove the wavelength for 162 and 163.
Right, because it's exactly the same.
Same. Mm-hmm.
It's just, you know, if you wanted to plot them individually, but you said you want to overlay them, right?
Yeah.
So we're going to overlay them. Okay. So let's just see how it looks to make sure this isn't too many lines. You probably want 3 graphs. You want your
Yes.
oh, I need to get rid of this. Okay, that's what you want. Pretty sure. Okay. I hate how it does that. 162. Okay, so we're going to have 3 graphs. Okay. There's too much stuff going on here. All right. Again, because I don't know. Oh, here's another thing. Okay. So see how it starts at 600? It starts like it reads. You want to actually read, you want the graph to show from 200 to 600, not 600 to 200, right?
Yeah.
So, we have to transpose this data. So I'm going to select the data and do a transposition. So we start from 200 to 600, not 600 to 200. Okay. So for that, you go to data, sort by which column? Wavelength. We want the wavelength to go from the smallest to largest, not the largest to smallest. And that changes it all. Okay?
Wow.
Because the way the scan, it scans the opposite way, so you have to transpose the data.
Okay.
Again, if you wanted it the other way, wavelength, and you wanted it to go back to where it was, you can do it like that. Okay? Well, we don't want it like that. That's not the proper way to
Okay.
do it. So
So
we're going to go from smallest to largest wavelength. Okay? And it's based on the cell values.
so instead of wavelength, you can select something else.
You don't want to. You only want to select what stays the same.
Okay.
All the absorbances are different, and you want
You
so-
select only the thing that are same.
Yes, right. If you selected something else, it would make
would
no
make
sense
mess.
at all. Yeah. Okay. All right. So we got that, and I'm gonna just go ahead and. Oh yeah, this is a lot of. So see, it takes it goes up by increments of 1 nanometer. So something else you can tell it to go every 5 nanometers or whatever. You don't have to have it all, but it's okay. All right, so let's just plot this and see what this looks like overlaid, like you showed in the paper the way they have it. Go to insert, and then it brings up charts, and the proper chart would be a line graph. Okay, so remember I was telling you we don't want to see this. We only want this part of the graph.
Mm-hmm.
So, because that makes that look so small, we can't see anything. So see how this selects let's just graph up to 250, okay?
Mm-hmm.
Oh, that's another thing that's annoying. So let me cut this. Cut. I'll bring it back. Okay, we know this is comparing the HUX to the HUX plus DNA. So see, when you click on the graph, it selects that data over there, okay?
Okay.
We want to start, we only want to graph from 250. Let's see how that looks, okay?
Okay.
There's a lot of not interesting things going on over here. So, where we start to see it flatten out, let's just go to 450. How's that? You see how it's just, there's no data out here?
Yeah.
We don't need that, do we? We don't need to go all the way out there. So let's go to, so we go to 250 here. We start seeing something at 300. So let's go to 450.
Okay.
So we've still clicked on the graph. You can unclick and click on it, and it'll show you what data is being plotted.
Okay.
But we're only going to go to 450. We're not going to go all the way out to 600. It's just not interesting.
Go to 450.
Yeah. So yeah, Excel is very, very flexible and user friendly to make your life
when you know
easier.
to use it.
There we go. You can like change the shape to make it look more square.
Yeah. Nice.
Okay, so there's your absorption spectra for those two. Sometimes it does something like this. It's just because some of the data is falling below 0, and that's just because the spectrophotometer, it's just that kind of variation in the light, you know.
Mm-hmm.
I mean, if you don't like that, it'll cut off that tail a little bit, but you can set that to 0, so it's not point blank, you know. As long as, but it does kind of cut the data off.
Oh, no, I don't think it's good at that.
Okay. Leave it there. You want to leave it there?
Yeah.
Okay. I'm going to stretch it out a little bit so we can see it goes to 450.
Yes.
And so we want all our graphs to look like that. We
Yeah.
want them to match up in the dimensions and all that.
Mm-hmm.
You
The
can
same-
have, you know, you
same
can.
size.
I'm gonna let you fiddle with whether you want a chart title. You know, you just click and put a title in. I'll let you fiddle with putting absorbance. and fiddle with putting that this is
the wavelength.
wavelength, absorbance wavelength. That would be I'll do the first one, the proper title
Okay.
for that. So, and then you can do the rest and give it a title if you want to.
Mm-hmm.
So the proper way, absorbance units. Okay?
Yes.
And then this will be absorbance wavelength. And we're just going to say, even though we know it is, it's just
It's
in
nanometer.
nanometers. Yeah, your units. Okay?
Mm-hmm.
I don't like the way Excel kind of just defaults to like not having a line there. So I like to put in a line. So you just click on that axis to put in a line. I just like that better. I generally, I would take this off because I don't like that the, you know, baseline is showing that. But that just,
Yeah.
but if you know, that's your data and that's the way it looks. So just keep it there.
To take that off, how you do? Like you just did previously?
You would double click here and this window comes up and it tells you
the minimum that you want.
yeah, so if you said you wanted it at 0, okay, reset it. We wanted it at 0. The only thing is it cuts off that tail. It just cuts it off.
Oh, that's what it is.
You know, if you want to reset it to what it would
Was.
defaults at, then that's fine too. If that, you know,
Okay.
it just, you know, it's just a little
Yeah.
aesthetic thing. Now, if this went really way below, then there's something wrong with the instrument or the, you know, there's something wrong with the baseline. The background subtraction wasn't good or something like that. But, you know, that's just showing you there's just a little bit of, it doesn't stay, your baseline isn't going to be perfectly zero because you're working with light and a mechanical thing that just, it wavers just a little bit. Not much, just a little bit.
Mm-hmm.
But if you want to just, you know, yeah, I mean, you could set it at 0.01. You know, does it still, you can still see it.
Yeah.
You know, you can play with it. And so anything you want to change, you would, you know, change here. Say you wanted to see all of the numbers, you know. Again, when you change that, yeah. Okay, so are you happy with the way
Yes, I
we
do.
would present this
I do.
data? Okay,
I do.
so that's the way. And the only
It's
other
perfect.
thing, okay, so the only other thing, because a lot of times when you take this and you copy it, this print gets really small, you know, or if you save it as, so another thing I like to do is save it as a picture, for example, and let's just put it on the desktop as Lydia Apps. For example, I just want to show you
Yeah.
that you may want to adjust the font size. So, because
Select.
oh god, okay. No, I don't want that. All right. Oh, I don't know. I don't.
Because you open with the paint,
I did. I don't like it.
a photo.
Okay. So, you're not going to have a graph that big in your publication. You know what I'm saying?
How you size it?
Yeah. So here, I just wanted to show you if I. Oh God, let's try this snipping. Wait a minute. Oops. Undo that. All right. It like overlaid it on there. I don't want that. Okay. So you're not going to have something this big. If you think about a 8 by 11 page, something in a publication, this thing's going to be shrunken way down to something like this. You know, that's probably, you're probably going to shrink it down to that or even more in a Word document, right? So you just notice it's very difficult to see.
To read.
Yeah. So this is just where you would select this and you would select your font size. I'm sorry, font size. Where is it? Oh, sorry. Oh, okay. Yeah. For publication, 16. 16 for publication. Because now you'll be able to see it. For the axes labels, 16. And for something like this, 12. Okay? And then even that, you can't really see it, right? Like, I'm just... Dev has had us have a whole protocol for how graphs are presented, the fonts, everything must be the same, blah, blah, blah. So I would make that. That's good. 12. If you don't like it in a line like this,
Mm.
you can just squeeze it. Okay. Whichever way you like it. Or you can just leave
At
it
the
like-
bottom. You just took this off and up there?
Yeah, well, what I did was, because sometimes you can't put this here,
Yeah.
and if I'm going to put it in the graph and not below the graph, I like to have it stacked because it mimics the way the data are presented. You know what I'm saying?
Yeah.
This by itself looks like that. This with the DNA looks like that.
Okay. Yeah, that's fine.
So, yeah, so I'll let you play with that, okay?
Mhm.
I'll let you play with that, how you want to show it. I mean, sometimes I'll just let you play with it because, different styles. This is significant. This is something that would probably be in supplementary information, but as long as you present it the same exact way. Because now when you save this as a picture, mainly the font size is important. You want people to be able to see it. No. Why do you do that? Photos is nice because you can directly copy from photos. Oh, it's doing that again. Okay. So now if I shrink this, you should be able to at least see the axis labels and the...
Compared to this one.
Yeah, if I shrink it just this small, which is something you might see in a publication, you can clearly read that that's
Okay.
absorbance. This is like 0.1 is so once you shrink it down,
Okay.
that's just something. So all you have to do is click on this and it tells you that's 16, so you would do the same for all the graphs. That's 12, that's 12, that's 16. You can change this to, a lot of times people will use Arial for scientific publications. But when I did that, see what it did? It changed the font size. So I'm just going to undo it. So that looks fine. I can see that fine. Because generally you're going to, instead of copying and pasting this directly into your document, you're probably going to save it as a picture.
Yes, picture first.
Yeah. I mean, if you don't like the lines, you can take those out.
Oh, you can still take the line out. How you do it?
I'll undo it. All you do is select.
Yeah.
You like a left click. You select left click, and then you just press delete. If you don't like the lines. If you like the lines, you can keep them.
No, the publication doesn't have the line on the graph.
This is true, and I
Yeah.
always take them out.
Yes, that's how it look like.
We don't really need those lines for this simple data. Now, if you have a whole bunch of bar charts or something, you have a whole bunch of, like, say you have a scatter plot, it's just, and you just can't make, you might want a line to look across. But yeah, in publications, they generally don't have lines. And generally, they don't have titles either.
Yes, that's one.
That's all in the figure
Yes.
legend.
Just the legend
Yep.
and the axis and the y-axis.
And the other thing is, if you want to change the color to make them look more different, you would select on this, And you can change your outline as any color you
Oh.
want. Like maybe you want Hux fluoresces really bright blue, you know? I don't know.
Yes.
And you might make this something that's really, really different like that. I don't know. You know, this is the one with the DNA. So, but, you know, so that's what's nice about that. Oh, I don't want the lines for sure. So you can fiddle with the colors. But whatever you do, just be consistent for all of them.
Mm-hmm.
So there's that. So I'm just going to leave that. I'm gonna,
Yes, yes.
One thing I haven't done yet is a emission scan. So let me do that so you have that data. I've set the gain so we can get it, okay? And the scan does take a while, okay? Emission scan. I've got the excitation scan in there. We'll work on that in a minute. And you want your colors to be the same throughout. Okay, anyway. So our excitation, not this, yeah, this is a scan. Okay, you're right. So I can't remember what I did before, so this is what's nice is that you can go back to the first excitation scan. We started, oh, that's excitation. Emission spectra. Okay, we haven't worked this data up yet, but it tells me what I did. My excitation wavelength was 350, and I went from 400 to 600. So I just 350, right? 350, 400 to 600. Bandwidth. We don't need anything else. Yeah. Wait. Okay, so that manual, it'll be over. Because remember, this is 2 micromolar.
Mm-hmm.
And it was over before, so we're going to change that. But all that, you don't have to worry about it.
200 microliter.
What?
200 microliter.
200 what?
Are you talking about the first row?
Oh, the first one is the highest concentration.
Yes.
And in triplicate, you know.
Mm-hmm.
So I was just setting the gain lower because we know from previous result that was over if the gain was at 100. You know, it was way too high and I couldn't see it. So this is just a repeat of what's already been done, but that's, you know. So the first thing you show is your absorbance scans.
The first thing to show when I'm going to present my data.
Yeah, you're characterizing your compound. So the first thing is, what does the absorption spectra look like? Absorption spectra. You're comparing your Hux to your Hux duplex.
Yeah. For the characterization. Absorbance. And then,
Yeah, and we can just kind of do you guys use PowerPoint?
yes,
Okay.
we do.
Yeah, this doesn't have PowerPoint, so we can't. I never got Microsoft Office on here, so
Oh.
the Excel comes with the.
How you got the Excel then? It comes with this
Yes.
software.
Yeah.
Oh.
Yeah. So I just we could use that computer, but then we'll have to transfer it. But basically, what I wanted to show you is that you're going to have all your because you do it in PowerPoint, right?
Yes.
Okay. So slide 1. You know, 1, 2, 3. Absorbance spectra. getting tired, can you tell?
Yes.
Okay. And then I guess underneath it, we want the fluorescence spectrum, which is what we're collecting now.
Mhm.
Again, we'll overlay the duplex, with the duplex and without the
without the duplex.
duplex, so it'll matches this. You see what I'm saying? Overlay with the duplex and without the duplex. Well, same thing. We'll overlay with the duplex, without the duplex. I don't know, you know.
Mhm. Yes.
He might ask about the excitation scan.
Mhm.
He might. You could probably, when you shrink everything down, have all of these on the same thing. Okay. And that's just going to be one thing, I think. I think I also did with and without the duplex there. Okay. Absorbance spectra. How does it look? How does it look by how brightness? Again, you know, you're going to say, underneath this, you're going to say, you know, you're also going to say how the duplex was formed. So you're going to have your, like, legend underneath.
Yeah.
So you'd say duplexes were formed like in cathodiolite, you know, and then you can say, you know, it was 10 millimolar of that, and 100 millimolar of sodium.
So that should not be talk about that duplex form. You say what is that duplex form?
It's just how
I make the duplex.
Yes.
Yes. I wanted to say, I should not talk about this before start showing the spectra.
Oh, you can say this first.
Yes, that's what I'm asking.
I was thinking for publication.
Oh, okay.
But yeah. You maybe your first slide. This might be slide 2. So slide 1 will be how
I make a duplex.
How duplex is prepared. That'd be 1, and then the ratio of hux to duplex was 1 to 1, which was 2 micromolar or ligand. You can say ligand. You can say ligand because you got 3 different things here.
Mm-hmm.
3 different ligands that you're comparing. 2 micromolar ligand, 2 micromolar of duplex. Okay.
Mm-hmm.
So the other thing, you know, maybe for your own information is that, you know, I mean, it should be obvious in the graph.
Okay.
Graphs. I think that's everything. Yeah, so you have slide 1, slide 2. And you probably have a slide 3. Because he's going to be interested in what the single point is at the at the fluorescence maxima. Because that's basically all you're really comparing, you know?
Yeah.
Because sometimes he just likes to see a bar chart. Let's see how this is looking. Those are our triplicates for Hux, triplicates for 162, triplicates for
163.
3. They all look very similar. Maybe they're the derivatives are a little lower, sort of. But, and then this is Huxt.
Yeah, without DNA, without duplex.
Yeah.
And 162 without duplex.
Yeah, right. No, it can only do so many. So this is really nice because we can see what the data look like before we plot it.
Okay.
But yeah, it might be useful to, also just show that you did this in triplicate.
Yes, that's why I was about to ask if it's interesting to show like this before plot it to the screenshot.
Oh, sure. Okay. We can't put all the data on there, though. It only lets, I guess what I was saying, yeah, you can do a screenshot. The only problem is it only lets you put like 10. It won't let you put all 12. So what we could do, okay. So we could take these off and you can do a screenshot of that. The only problem is nothing's labeled. I don't know if you can label this. It won't let you label.
It won't label.
Yeah.
That means no interesting.
Yeah,
because
it's like,
no one is going to know what's that.
Yeah. I mean, it's real pretty and everything, but we don't know, and it plots it. I like the axis. I like how it plots it. But yeah, and you can see how many data points you collected, every single increment of 1 nanometer, that you were very thorough. But yeah, I mean, so that's why you have to graph it if you're gonna. I mean, the other thing is like, okay, here we go. If you don't want to show the triplicates, you just want to you still won't have what it is, so never mind. But yeah, let's just look at what these look like. So Hux has, a little bit of fluorescence by itself from the get-go. So this is without the duplex.
Without the duplex.
So Hux has a little bit of fluorescence. It's not much compared to
the DNA
duplex.
duplex.
It's like not there, but compared to the derivatives, it seems to be emitting more light from the beginning.
Yeah.
But it's not that, it doesn't really matter, because I mean, what you could do, I mean, what they are, right?
You get the ox with the DNA and the ox without DNA.
Okay, yeah. So this last one I did, 163 is actually higher than Huxt. A little bit higher.
That's 162. No, it's 163.
Yeah. Huxt, 162. Let's go back.
Yeah.
Huxt, we did it in triplicate, 162. They look the same.
And
even though it doesn't seem to be absorbing light. So I'm glad we repeated all this. Because yesterday was just, let's just do and see what happens. But today we repeated. Hi, you're back safely.
Yeah.
You didn't fall asleep at the car.
That means we are walking again. Drive through.
We've been working straight through. We haven't taken a break.
Okay, just wait.
okay, please.
Okay.
Yeah, I'm just depends on how much time.
No, he said he will just wait for us to finish.
Okay. You just let me know when you're done.
No problem. Let's just do it.
So this is interesting,
Yeah.
This 162, even though it doesn't absorb light very well, it's just as fluorescent. And it looks like 163 is brighter than both of them.
163 has more fluorescent than the ox.
Yes, right. But this is where when we do things in triplicate, is that a significant difference? You know what I'm saying?
Yeah.
It could be their error bars overlap and there's really no difference between all three. And you'll probably, and so, when you're also going to repeat this experiment, you don't need to do all the dilutions. You just need to do 2 micromolar, 2 micromolar. You don't need to do all this other stuff that I did. I was just doing that because the plate reader is just very.
Half a space, or
It's just. I was worried about saturating the detector, and I have to work through, the gain. The gain was the main thing. I had to lower the gain so it wasn't so frickin' bright. Anyway, so I mean, you could take a picture of that if you wanted to, but you also have it on the video.